Hi there. Now that we have laminated the outside of the top side, it's important to carry on and not stop here, because we might get shape changes. So thus I need to carry on with the inside of the top as well. So we will start outside with some sanding. So let's go there. I start with removing the worst excess with a belt sander. This is not the best tool for the inward bending surface, but by tilting the sander I can remove some material until I have to resort to hand sanding. A dusty experience where I have to vacuum afterwards. I lay back the front panel and continue with the aft deck. This part has less bendy surfaces, so I can use the belt sander to take down the high edges. But eventually I have to change to hand sanding again. Now I extend the deck with the aft hatch. I was planning on delaying this to later for easier mounting of the deck, but realized the aft deck was too fragile and needed support from the hatch area to take the violent sanding. There are some gaps in the hull that can't be sanded flat. These I fill with the lightweight epoxy fairing compound. When I prepared the compound, I think I made an error. You should take 19 grams of hardener to 100 grams of base. But something went wrong. When I start sanding after a few days, the laminate is not hard. I can scrape off fairing compound like old paint, so I have to take the labor with removing all loose fairing compound. After this detour, I take care to mix the hardener well. The hardener has high viscosity, so it's hard to measure exactly 19 grams. Instead, I weigh about this amount of the sticky product, using all techniques I can think of. Finally, I can put the lid on and calculate how much base I need to add. The base is much easier to work with. It flows better, and you can stop the flow at a more exact weight. Still, I have to remove 2 grams to get to the exact ratio. But this can be done with a stick. I mix well, but this is not a problem with this brand of fairing compound. It's also very nice to spread. Sanding it when mixed correctly is also easy. I wrap up with vacuum off the excess dust. I will need to strengthen this front deck to cope with the compression forces from the front stay. I plan on using anisotropic strength of wood, strong in the fiber direction, but with low weight. I also prepare a few pieces of wood to get a flat surface and get a smooth transition into the rest of the hull. I use cotton fibered thickened epoxy to glue the wood to the hull. Wetting both surfaces secure a good bond. I want no air bubbles between the two surfaces. I staple the strips in place to make sure good contact while curing. Here in the back end I also use wood. Here I want a light solution to create a smooth bend. So I glue on a strip to be able to sand a bend into it. I use clamps to get the strips to conform with the bend of the hull. Now I add a small amount of fairing compound to smoothen out a small gap along the strip. The day after I can remove the staples from the cured strip and sand the surface to get a smooth transition into the rest of the hull. In the back end I need to cover the holes under the clamps with fairing compound. After the last sanding, I can move in for the final step. I mix a batch of laminating epoxy. I saturate the surface with epoxy before laying down the glass. As I have a weak seam between the hatch plywood and the aft strip deck, I need to add a double layer of glass to strengthen the area. After wetting out the bottom layer, I can pre-wet the rest and add glass that will cover the rest of this panel. I start with even out the glass from the middle. Wetting out a surface that bends in the edges can easily lift the cloth from the surface if you don't take care and wet out the center first. When wetting out the area above the bend, you also want to work sideways for the same reason. I will strengthen the front more with extra strips of glass. Here I wet out a 300 gram biaxial glass above the extra strip. In the area around the hatch, I can't use wood for the extra strength. Thus I add one strip of 300 gram biaxial to spread the forces sideways. Strips on both sides of the hatch will carry some load past the bending area. Around the very bend I also add an extra layer of 150 gram twill glass, before adding the final covering glass on the whole surface. On the vertical sides in the front, I pre-wet with somewhat thickened epoxy, as this will minimize problems with dry spots and bad lamination, due to gravity dragging the epoxy downwards. Getting the glass down in between the sides is a bit tricky, but working from the middle and outwards, I get it to conform. In the very front, I need to hold the glass to the edge and push the glass down with a pencil before wetting it out. After a couple of hours, when the epoxy is still sticky, I add a second layer of epoxy to encapsulate the glass. I will not bother with a third layer, as a small glass pattern is no problem on the inside. This was all for this time. Welcome back!